In the last presentation, we completed 1:2 demux. In this lecture, we will study 1:4 demux. We are having 4 outputs, so n is equal to 4 number of outputs, and we want number of select lines m, and m is equal to log with base 2 n. So we have log base 2 4, or we can write it as log with base 2 2 raised to power 2. So m is equal to 2. Number of select lines are 2. Let me draw them. S0, S1 are the 2 select lines, and I have already made the table in which we are having 4 outputs y0, y1, y2, y3, and we will have enable S1, S0. When enable is low, it is 0. Whatever be the value of S1 and S0, all the outputs are going to be 0. When enable is 1, S1 is 0, S0 is 0, it means the input I is transferred to Y0. So Y0 is equal to I, and Y1, Y2, Y3 will remain 0. When enable is 1, S1 is 0, S0 is 1, then the input I is transferred to Y1. So Y0 will remain 0, Y1 is now I, Y2 is 0, Y3 is 0. In the same way, we can complete the table. 1, 0, I is transferred to Y2, so we will have 0, 0, I, 0. And when both S0 and S1 are 1, 1, I is transferred to Y3. So we will have 0, 0, 0, I. So this is the table for 4:1 demux, and we can find out y0, y1, y2, y3 expressions for them. Y0 is equal to, you can clearly see, E is 1 for all the cases, S1 is 0, S0 is 0, so we will have S1 complement, S0 complement, and I. In the same way, Y1 is equal to E, S1 complement, S0I, Y2 is E, S1, S0 complement I, and Y3 is equal to E, S1, S0 I. So these are the expressions, and we can easily implement them by using 4 input AND gate, 4 input AND gate, and we require 4 such gates. So let's implement the logic quickly. This is S1, S0. I will use one NOT gate, and this will give me S1 complement. In the same way, I will have S0 complement. Now I will make 4 AND gates. The output of the first AND gate is Y0. The output of the second AND gate is Y1. The output of the third AND gate is Y2, and output of the last AND gate is Y3. If we analyze the obtained expressions, we can clearly see E and I are common in all the expressions. So first we will implement E and I, then we will move to S1, S0. This is I, the data input, and it will act as one of the input for all the AND gates that we are using. In the same way, we will have the enable, this is enable E, and it will also act as the input for all these AND gates that we are using. For y0, we have S1 complement, S0 complement. So we will take S0 complement. From here I will have S1 complement. For y1, we have S1 complement S0. We need S0 and S1 complement. For y2, we need S1 S0 complement, S0 complement, S1, and finally for y3 we need S1 S0, S0, S1. So this is how the circuit for 1:4 demux looks, and in the next presentation we will start demux tree. So this is all for this presentation. See you in the next one.